For today's vlog, we will be doing an application of digital input and output using the microcontroller PIC16F18875.
The first thing to do is to create a new standalone project. After that, we are going to select mid-range 8-bit MCU for the family and PIC16F18875 for the device. For the compiler, we are going to use the XC8 compiler, and we're just going to name the project. Next, go to Tools, Embedded, and then click the MPLAB Code Configurator. For the MCC content, we are going to use the MCC Classic and click Finish. Next, go to Package and select PDIP40 and then unlock the port 0 to 3 from A and B, and then unlock the 0 from the port C, which serves as a switch. Next, go to Pin Module and uncheck all the analog and then rename the port names. After that, click Generate and then go to the main C file for us to be able to type the code.
So after generating the source files, we're going to be moving on to the code. So the code is just a rather simple code. It's just an if-else statement which contains commands on how the LEDs should be lighting up. So in the first line of code, it's going to be the if statement with if switch underscore get value is equal to 0. So basically, if the digital input is equal to 0, or if you're not pressing the switch, this is how the LED is going to light up. So first we need the delay ms command, which you're going to be seeing a lot, and it basically says that the LED has to wait 250 milliseconds before it lights up. And then the rest of the code, as you can see here, LED underscore RA0 through RA3. So basically in that order, that's how the LEDs are going to light up. That's for the first block. Right. So in the second block, it's going to be for the RB, the LEDs connected to the RB port, which is also 0 to 3. And then the third block, it's for the RB port, but now it's from a reverse order, 3 to 0. And then for the LEDs connected to the RA port. And then the else statement, or basically when the digital input is equal to 1. This is how the LED is supposed to go. So it's going to be the LEDs connected to R8 then RA2, and then RB0, RB2, and then the rest of the LEDs RA1, RA3, and then RB1, RB3. And then the only difference is that they light up together, because there's the only delay is at the start and not in each opening of the LED. So here's an overview of the code for the if statement, or the if part. And then scrolling down a bit, we can see the else for the else statement or the else part. As you can see here, there's only one delay for each block, basically, of the LEDs turning on. So that would be all for the writing of the code.
Now, when the PK tree is connected to the computer, we open the MPLAB IPE. Then, from the power, we check the voltage level it should be 3.125. And then we check the power target circuit from picket 3. Then back to operate, we double check the location of the file, and then click program. Then after that, the program from the file should be transferred now to the microcontroller.
So prepare the materials needed. So first, the 2 breadboards, a power supply, the PIC 16F18875 microcontroller, 8 330 ohms resistors, 8 LED lights, and a male-to-male connecting wires to connect the components together.
Okay, so for the attaching of the components to the breadboard, we will be using a breadboard power supply, and this will be powered by a typical power supply adapter. And then we will be connecting the microcontroller to the breadboard. Next, we'll be using a tactile switch. This will be used to control the LEDs. Since the tactile switch is connected to RC0 pin, then the tactile switch will be connected using a connecting wire to the RC0 pin. For the next step, we will be attaching the 8 330 ohms resistor for the LEDs. For the next step, we will be connecting the LEDs to the microcontroller. The first 4 LEDs will be connected to the RA0 pin, RA1 pin, RA2 pin, and the RA3 pin. For the second 4 LEDs, it will be connected to RB0, RB1, RB2, and RB3 pins. And then we'll be attaching the 8 LEDs to the breadboard. For the next part, we will be connecting the VDD and the VSS of the microcontroller to the breadboard. The VDD is located on the number 11 and number 32 pin of the microcontroller. This will be connected to the positive rail of the breadboard. For the VSS, this is located on the number 12 and number 31 pin of the microcontroller. This will be connected to the negative rail of the breadboard. Now to test the output, we'll be connecting the power supply.